Thank you so much for watching this online video tutorial. Please like, comment and share the video, and please don't forget to subscribe to our YouTube channel at Good Better Best Online Videos for more content. Good day and thank you for joining us. So in today's video we'll be covering probability. So just looking at what probability is, it says that probability is the chance that an event will happen. Okay, so moving on now, we'll be looking at certain terminology, so like sample size. Sample size has to do with is the set of all possible outcomes in a certain scenario, and then this is just how sample size is represented in an equation, right? Or if they're asking if sample size is how they represent it, and this refers to the number of elements in the sample space. Okay, so also just to throw some more terminology at you, or rather getting into an example first, if we look at rolling a dice, if we consider the sample space in rolling a dice, which is all of the possible outcomes, that includes obviously 1. So this is a 6-sided die that we're dealing with. So we're looking at rolling a 1, a 2, a 3, a 4, a 5, and a 6. So we have a sample space of 6 different outcomes, right? So let's just define some events that could happen, okay? Because remember, this is the chance that an event will happen. So let's define some events. So let's say event A is rolling a odd number. Let's say event B is rolling an even number. And let's say event C is rolling a number 3. Cool. So event A is rolling an odd number, event B is rolling an even number, and event C is the number 3, rolling the number 3. If we go ahead and look at the probability of each of these events happening, we can go the probability, so it's represented as the probability of whichever event you're seeing. So let's say they ask us to work out the probability of rolling an odd number. So we'll say probability of event A is equal to, so now what needs to happen is we have a fraction over here. At the bottom we have our sample size there, which is 1, 2, 3, 4, 5, 6 numbers, so or 6 different outcomes. So all your outcomes at the bottom, and at the top you'll say all of your favorable outcomes, right? And what's our favorable outcomes when we're looking at event A? It's odd numbers, so that would be 1, 3, and 5, right? So that's 1, 2, 3 of the outcomes, right? So it's 3 over 6, so probability of A is a half. If you look at probability of B, doing the same thing, obviously remember our sample size at the bottom with the number of possible outcomes, and then favorable outcomes at the top of even numbers. So that's 1, 2, 3 even numbers as well. And that's half. Then if you look at the probability of C happening, event C, so once again over 6, because that's our sample size of the total amount of outcomes, over the favorable amount of outcomes, which is rolling the number 3, and there's only 1 3 here, so that means that it's just one outcome. So that's a 1 over 6 chance that you will roll a 3 when you roll the dice. And the same goes for each number actually, because if you try and get a 1, still the chance of rolling that is 1 over 6, or 5, it's 1 over 6 as well. So that's just to explain to you guys how to apply a probability, right? But so now let's look at a combination, you could say. So this is a different type of thing they could ask you. So they say the probability of event A and. So this means and, okay? Sometimes they'll also say the word and, but most of the time they use the symbol. So the probability of event A and event C happening. So what we have to do in this case, so they're talking about intersecting, right? Where the two rules intersect. These things when they happen at the same time, okay? So we have to basically find out if they can happen at the same time, and then what is the probability of them happening at the same time, okay? And so if we do that, what we need to do is combine the rules or the events. So A and C, so that's an odd number and the number 3, okay? And so basically what ends up happening is we say it has to be an odd number and it has to be the number 3, okay? So we first have to check for our odd numbers, but then we have to look for the number 3, okay? And so in this case, obviously our odd numbers is 1, 3, and 5. but because the rules are combined, it has to be the number 3, okay? And so if we say that it has to be the number 3, so that means that we'll only have one possible outcome that we can deal with. So this means that the probability of event A and event C happening is 1 over 6, okay? Obviously though, this would change if it says number 3 and 5. Then the way to change is that we'd say, okay, the odd numbers are 1, 3, and 5, but you see, there are 2 numbers that apply to the second rule, right? And the second rule says number 3 and 5. So that's 1 and 2. So that means that it would then change here to 2 over 6, which is a third. But anyways, I think actually I'll just get rid of this now because it's not part of the example. That's just a bit of an explanation there. And then another formula that I can throw at you guys is the probability of A or C. So this means union, but it also means or. Sometimes they'll say A or C, but in this case they just put the union sign there. And basically the equation for this is we have to look at the probability of event A plus the probability of event C minus the probability of event A and C. Sorry, I messed up the sign there, but let me just erase this so we don't get confused as well. Okay, and so now we look at the probability of A plus the probability of C minus the probability of A and C, which we've already worked out all of them before. So probability of A is a half, the probability of C is 1 over 6, so that's plus 1 over 6, minus 1 over 6, which is the probability of A and C. And so obviously we know these will cancel out, and so that means the probability of A or C happening is a half. Then also, is there a possibility that we could do this by inspection? There definitely is. So the probability of A or C, what that basically means is that we do not have to combine the rules like when we do in probability of A and C, because it's or C. That means that all we have to do is consider all the possible outcomes that apply to both events and then add them together, okay? And so the way that would work is we'd say, okay, so event A is an odd number, so it'll be, okay, there's 1, 2, 3 odd numbers. And then the probability of C happening, which is number 3, would be the number 3. But you see, the thing is, we don't double count numbers. So, which means the probability will stay as 3 over 6. Because we've already counted the number 3 when we looked at odd numbers, we cannot count it again. Okay? So we only count each event or each outcome once. Obviously though, if there was more data and maybe we got extra numbers, then we would add on. Okay? And so you can see that 3 over 6 still gets us to a half to confirm that outcome. So what happens now in mutually exclusive events? What are mutually exclusive events? And I personally feel like it's better to explain what it is via a example. So let's look at events. We have an event A here. So let's say you were going to go and choose a car to buy, and the different choices were, well, let's just put it here as in, okay, so the colors that you want to choose. Here's the color red, and then the event B is the type of car. Let's say a Fiat. I'm just putting in random stuff here just to show you quickly what mutually exclusive is, and this is blue. Okay, so obviously I'm not showing you all of the data. In the next example I'll try and explain this a bit better, but just to show you what mutually exclusive events are, if they told us to work out the probability of A and C, what we need to show them is that we know what they're talking about, right? Probability of A and C, that is event A being a red car and event C being a blue car. Remember now what has to happen is we have to combine the events, right? Can these events happen at the same time? That's what mutually exclusive events are looking at. If these events cannot happen at the same time, then these events are mutually exclusive. Okay? They cannot happen at the same time. So if I choose a car, what I have to understand is that it will either be red or it will be blue. It cannot be red and blue, right? Because the options aren't there unless they tell us that there's an option of a red and blue car. But in this case, it's either a red or a blue car. It's not a red and blue car. So in this case, the probability of A and C happening is 0. Okay, so when it comes to mutually exclusive events, it will always apply to your probability of A and C or A and B to the AND equation where they use this sign, right? It will only apply to the probabilities where they use the sign of intersection over here, right? And so if the events are mutually exclusive, it will always equal to 0. If they're not mutually exclusive, which means they can happen at the same time, you have to find out the probability of it happening at the same time by inspection. Then the next thing that we need to look at are complementary events. Okay, and so what a complementary event is basically defined as, in say the event A, as that event A will have a complementary of A with this dash over there, okay? So if you're looking for complementary events, we're always looking for that dash next to the letter. And so basically what these complementary events are is that this A with a dash basically stands for everything in the sample space that is not A. So let's say that in the example above we have identified event A as red. That means that everything but the color red, okay? Every car that isn't red is considered as part of the complementary, okay? So let's just say everything. Okay. So technically, a very quick way of doing this is that obviously if the, let's throw some numbers out there, if the probability of event A happening was, let's say 5/9, that would mean that, so this was event A, right, is equal to, so because it says that everything in the sample space that is not A, that means that probability of A plus the probability of A with the dash is equal to 1. Okay? And if that's the case, that means that the probability of the complement of A, right, is equal to 1 minus the probability of A. Okay? And so that's it mathematically. So that means that in this case over here, the probability of the complement of A is equal to 4/9. And it's that simple. So what we're going to do now is just have a look at examples pertaining to what we have just learned. So it says here, Derek needs a new car. He can choose between an Opel, Volkswagen, Ford and Fiat. White, blue and red are the choices for the color of the motor car. The first instruction is to draw a two-way table to represent all outcomes. And what a two-way table is just a table that's defined, both axes are defined by the different variables given to us, or the different events, and while the variables which will determine the different events. And so what we're going to go ahead and do is just fill in the two-way table. And so what I'm going to do is I'm going to put the colors here on top. So this is going to be white over here, this is going to be blue over here, and this is going to be red. Cool. And on the left hand side we'll put the name of the cars. So we'll go ahead and put Opel first. Then it's Volkswagen, which I will identify as a VW. Then we have Ford and Fiat. Cool. Now to complete the table, what we need to do is fill in each block over here in the middle, and that's basically done by crossing the two together. So we have white and Opel. So we'll say it's a white Opel, a white VW, a white Ford, which I'll identify as F, and then a white Fiat, which I'll identify as Y, W, F, I, sorry. And then a blue Opel, a blue VW, a blue Ford, and a blue Fiat over here, right? And we have a red Opel, a red Volkswagen, a red Ford, and a red Fiat. Cool, and it's just like that our two-way table is done. That's as simple as it is. Both axes filled with the possible with the variables, and the inside filled with our events that's taking place. Cool. So here they give us the defined events. The following events were defined. So event A is having a blue or red car. Or is the very important word here, guys. They're not saying and, they're saying or. So that means we can consider both at the same time. Then it says B, a white car. So that's event B, a white car. And then event C is the name of the car, begins with an F. So right here on the right hand side, they have what they want us to work out. So it says here, determine first the sample size. Okay, so we're going to go ahead and do that. And the sample size obviously defined by these events all here in the middle. So which is 1, 2, 3. 3 times 1, 2, 3, 4. So that means that our sample size is equal to 12. Okay. Then what they ask us to do is work out the probability of event B. Or not work out, but determine. So the event B, remember, possible outcomes at the bottom, favorable outcomes on top. Event B is having a white car. So that means this whole column over here we'll consider. So that's 1, 2, 3, 4. And that means that the probability of event B happening is a third. It's always important for us to simplify the fraction. Then it says here probability of the complement of B. And that obviously we know is 1 minus a third to give us a 2 over 3. And only minusing this third because that was the probability of B. And remember that the complement of B is everything else in the sample space. So the quickest way is just to say 2 over 3, which is left over from 1 over 3, right? Or you could go ahead and count 1, 2, 3, 4, 5, 6, 7, 8. 8 over 12 gives me 2 over 3. And then we look at the probability of the complement of C. So the name of the car begins with an F, is the event C, right? So that's these whole two rows over here. So that's 1, 2, 3, 4, 5, 6. So we can just write here a note to ourselves, or we can write actually, preferably write it in your working out. I just don't have space there, so I'm just going to say here the probability of event C is equal to 6 over 12, which is equal to a half. And so therefore, then I can come here and I can say the probability of the complement of C is going to be a half as well. Okay, because that's what's left over if you minus a half from 1. Sorry. Then it says the probability of event A. It says a blue or red car. Remember, it's or, so we can consider both. We find out first all there for event A, all for the blue, all for the red, and then add it together. Okay, so a blue or red car. Blue 1, 2, 3, 4. Red 1, 2, 3, 4. Add them together, we get 8. And so that's 8 over 12. Simplified gives me 2 over 3. And that's the probability of event A happening. Now we're getting to our ands and our ors. So we have probability of event A and B. So firstly, remember when it comes to the and, we're going to do it by inspection, okay? So probability of A and B. So let's look at event A and event B. Event A is a blue or red car. Event B is a white car. So remember now, we have to determine whether these are mutually exclusive or not before finding out what the probability actually is. And if it is mutually exclusive, it's equal to 0. So obviously, if we're looking, if he chooses a car, if Derek chooses a new car, basically event A is saying it could be blue or red. Event B is saying it's a white car. It's definitely a white car. And so remember, if he chooses a car, it cannot be blue or red and a white car. Okay, so that means that these events are definitely mutually exclusive, because he's not going to get a multicolored car. The car is going to be one color, and so that means that the probability of A and B happening is 0. However, now looking at the probability of A and C, so event A, remember, is a blue or red car, and the probability of C is the name of the car begins with an F. Okay, so what that means is that we need to consider, okay, when it comes to the events not being mutually exclusive, let's combine the rules now, okay, or the events. So it has to be a blue or red car, but the name of the car must begin with an F. So blue and red cars, obviously these two columns over here, right? But the car must begin with an F, because remember, both rules have to be, or both events have to be respected. And so that means that we will only look at these four here at the bottom, right? Because here's all the cars with the F, here's all the blue and red cars, but we can only look at the intersection part, okay? So that's 1, 2, 3, 4. So that means that is 4 over 12, which is equal to a third. And then just to get some space here for the last question now, it says the probability of B or C. And so remember, when we see the or, it is a calculation. Okay, so probability of B or C. So you see in this question they've asked it with the words, right, and or. I just prefer writing the symbols because those are quicker. So the probability of B or C is equal to the probability of B. Remember, we have to break this up now. Probability of B plus the probability of C. So whatever we're working out for, we'll split it up here in the working out. So probability of B plus probability of C minus the probability of B and C. Okay? And so the probability of B, did we work it out? Yes, we did. It was a third. And then the probability of C, we also worked out. It was over here. It was a half. Minus the probability of B and C. We didn't work that out, so let's just check quickly for the different outcomes, or we can do it by inspection quickly. So the probability of B is a white car, and C is the name of the car, begins with an F. Because it's and, that means that the car must be white and it must begin with the letter F. And that would refer to both of these cars over here, the white Fiat and the white Ford, right? The white Fiat and Ford. So that's 2 of the possible 12, which will give me 1 over 6. Correct? And then what you'll do is you'll just punch that in on your calculator, and that will give me a final answer of the probability of B or C equals 2 over 3. I can just go ahead and write that in over there. And just like that, we've applied everything that we learned in this video. Thank you so much, guys, for joining me, and I hope to see you again in the next one.